Welcome to Let's Make a Game Platformer, episode 44. In last episode, I've added the list of blocks and something that allows us to select the block and only one block at a time. In today's episode, I'd like to continue on placing blocks in the level editor. And to do that, I'll start off by implementing a controls in the editor. So we'll have a package controls here. And I'll have mouse control, mouse editor control class. It's going to be a system. So I have to register it. And I want to register it in profile, game screen, and editor. Okay, so in here we'll be receiving, first of all, I want to track the position of the mouse and always keep it, position of it being tracked. So for that I'll be receiving an event. And we had the mouse moved event that was being sent in our control. And the mouse moved has a couple of information. Here is a screen X and screen Y. So let me extract it here. Okay, and now we have to figure out how the screen position. So you can imagine screen X being 0 being on the top left and increasing in X and Y depending on the location to the bottom right of the actual window screen, game window. And we have to figure out how this translates to actual position in a 3D. So to do that, we have to ask the camera where the camera is and how does the position on the screen translates to a position on the camera. And to do that, we will inject here a entity. What was it? What was the name? Entity. Rendering entity. So it's the rendering entity provider that gives us information about the camera. And if you looked at the previous episode, which was the refactoring one, which changed how the camera works, and this is one of the reasons why I changed this. So I can now get camera event to the entity, and I have to provide the width and height of the display, or the screen, and game screen, and I have to send it to the rendering entity. I have to send this event, and after that I have the camera here. And on camera, I can now ask the camera to give me the peak ray, which is the ray from the camera going towards the screen, and it hits the screen at the position screen X, screen Y. So this is basically, ray has a beginning, so the origin where the camera actually is, and it has a vector that points in the direction that this particular point is. So if you select the position directly in the middle of the screen, for example, you can imagine the ray going straight, and it's going to look like a point for you, the whole vector, because it's going to be vector is going to be 0, 0, 1 or -1 depending which way you're looking at it. So I can get a peak ray, which allows when I pass the screen X and screen Y. And then from that peak ray, I can use an intersector that is part of the libgdx, and I can intersect this ray with a plane. Plane is something that has an origin and the direction. So in math, for example, in our case, the plane is going to be always, because our camera always looks straight ahead, so our plane is always going to be having the same z coordinates. So there's a couple of ways of constructing a plane. One is specifying a normal, which in our case is going to be opposite what the camera is. So in our case, the normal will be, it's going to be 0, 0, and 1. And the second parameter is the, I will use the second constructor with a float here, which is a distance from the origin. And in case of our, because all our elements by default are on a 0 coordinate, we use this 0 value. However, if we, for example, I'll add later a ability of moving the camera or the whole editing plane forward or backwards to be able to edit blocks with a coordinate z coordinate different than 0, we'll be modifying this. So let's maybe extract it here to remember what it is. Z coordinate, and the third parameter is the result that we'll receive. And if we receive the boolean here saying that whether something was intersected or not. And if we are intersected, we want to send an event. Let's call it mouse tracked event. And here I want to pass the position. Okay, so this will basically give me a position of the, so I'll use the level I'll have a level here, entity, similarly to the here the level editor. I have level entity. I'll do the same here to load it, and I'll send an event with this position to anything that might be interested in receiving it. So I'll have here a level entity assigned, and on every mouse move I will send an event saying mouse tracked result. This is very ugly at the moment because I'm creating a new vector on each one, on each call, and the same here. This could be improved, but for now maybe I'll just introduce this plain normal to have only one value always, so I don't reuse the same object, so I don't create a new one. Result at the moment is going to be this, created every time. I can change it later. Okay, so now we have always will have the position of the mouse on the screen in a 3D coordinate based on the z coordinate. Okay, so now let's maybe use it. So in the editor, I'll create here a rendering package, and I'd like to render a cube at the position that is being selected. So let's do it selection renderer. And what I want to do is, first of all, I want to keep track of the position that is being selected. So I'll be receiving an event. Let me do it here, receive event. Mouse tracked. And in here I'll have mouse position, and in here I will store it. Okay, so this system will always remember where the last position was that was selected, and I want to now render something. So in here I'll have render cube with the render environment event. I want to, okay, have to remember to put this only in the game screen and editor profile. We don't want to render anywhere else. And in here, I want to be able to render the actual environment, so the actual cube. However, I don't want to render a cube that's going to be filled out. I want to render only frame of the cube. And to do that, I have to create a model, like with everything. So I'll have lifecycle system here, and in the initialize method, I will have a, first of all, model batch. And I will have a model instance here and model. Okay, so first of all, I have to create the model. And to do that, I will use, which approach I will use? Let's go with the approach of me specifying all the lines. So I will create a array of floats to specify all the lines, all the vertices. And a cube has 8 vertices, right? So we'll have vertex at 0, 0, 0, vertex 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are all the vertices of the cube of the size 1. Maybe I'll in here introduce size, and instead of specifying 1 everywhere, I'll just specify size, because later on I can change the size of it. Okay, so we have these all vertices, and now I have to specify all the indices, so index to specify each line. So for that, we will have to first of all connect all the, and because I'm specifying lines, because I'll be drawing lines rather than sides of the cube, the order doesn't really matter when you specify lines. So I'll specify, so this is index 0 vertex, index 1, 2, 3, and so on until 7. So cube has 12 lines, right? Because you have 4 on the top, 4 on the bottom side, and 4 lines on the side. So we have 12 lines. So let's go with First, we'll connect these 4 lines. So 0 to 1, 0 to... so they have to have one of the same, 0 to 3. This is wrong, there should be size here. Right, yeah, okay, so 0 to 1, 0 to 3, oh, sorry, 0 to 2, and so we have 0, 0, 0 to this one, 0, 0, 0 to this one, and finally we want to have this one to the last one and this one to the last one as well. So we'll have 1 to 2 and 1 to 3. So we have on the bottom, so this is with the x0, so we have one side finished already. Now we will do the same with these. So basically we add 4 to each of those. So we have 4, 5, 4, 6, 5, 6, 5, 7. Okay, so we have these, and now we have to connect the lines, this line to this one to this one, and so on. So we'll have for distance of 4 in the indices. So we have 1 to 4, 0 to 4, 1 to 5, 2 to 6, and 3 to 7. So these are on the indices of the cube lines. And now I'll have to create a mesh part with it. And mesh. Okay, how do I create the mesh? Okay, I say that this is a static one, so it doesn't change. Number of vertices is going to be the same as always, divided by 3, because each vertex is the length of 3. Then number of indices is going to be this, and vertex attributes. So, so what do you want to have? We want to have color attribute. We want to have position and we don't care about color, I think. Yeah, let's go with this for now. So we have this mesh, and mesh set vertices, mesh set indices. So we have mesh, then model builder, part, I specify ID, cube, this is whatever, mesh, and here this is the important part, primitive type, GL to 0, GL lines. So in here we specify that normally you would say that these are triangles. These are triangles or anything else when you want to stuff. However, when you want to render lines or points, another thing you can pass here is points. It's gonna, depending on this setting, it's gonna interpret the vertices differently and the indices. So when it's, for example, looking for triangles, it will take three consecutive indices to build a triangle from the vertices here. However, when you specify lines, it takes 2. When you specify points, it takes just one index per point per the primitive that you're going to be rendering. And then here we'll specify material, and we'll specify color attribute diffuse. Let's go for now for white. Okay, so we have this returns a mesh part. Actually, no, I want to have model. Let me come back to this in a moment. I have to figure out how to do this quickly. Okay, I think that should be fine. So model builder, and gives us a model that we're gonna store here. And finally, I want to create model instance from it. And in here, first of all, I'll get the pipeline. Make sure I'll draw to the current buffer. Finish drawing to the current buffer. And finally, I want to model batch begin with the camera. Model batch end. And model batch render the model instance. Okay, so this should render it always at position 0, 0, 0. Let's check it. Okay, so we have cube with some problems. I probably got the indices wrong, but we have something rendering already. So let's figure out. Okay, so I've fixed the positions. Now the cube is rendered correctly. These are the correct indices. Okay, so now we are rendering it, and I want to make sure that we render them at the correct position. So to do that, we will get model batch, model instance, transform. First of all, we make sure that it's identity, and finally we translate it by the mouse position. Okay, so now the position of the cube should follow the mouse. Let's see if that works. Okay, there is a problem here. Okay, so we have to do the rendering only if the mouse position is not null. Because if it's null, then it means that we haven't really, the mouse is not even on the screen, was not on the screen ever. Actually, maybe I will render. No, okay, yeah, that should be fine. So if the mouse was never on the screen, we're never gonna render the cube. Okay, so now our cube follows the mouse. But as you can see, it actually follows the pointer of the mouse is pointing at the left, further away bottom corner of the cube, because that's our origin of the cube. And it would be probably much better if it was pointing at the middle of the cube. So middle back side, so middle of the back square, furthest away from the camera. So to do that, I have to actually modify the mouse editor. Sorry, the selection the mouse editor control, and I have to subtract from the resulting vector. I need to add the 0.5, 0.50 to it. So this should be, now the mouse pointer should be pointing at the element in the mid, at the rectangle at the square in the middle. Okay, wrong. It should be subtracting. Okay, so now it's doing very well. Okay, so another thing I'd like to do, maybe rather than doing it here, in the selection render, I'll have a separate vector here for the position, and in here whenever this is being set, I will do mouse position set to whatever it was, -0.5, -0.5. Yeah, so rather than doing this in the mouse tracking, which doesn't make sense because we might want to have, for example, a point for something else rather than being pointing at the cube. The cube, the fact that we want to be on the middle of the cube is done in the renderer itself. Okay, so let's run, make sure that everything is still working the way it was before. Okay, so everything is fine. And so another thing I'd like to do is that if you were to place blocks by hand, one next to each other, it will be really difficult because you will not be able to get exactly what position 0, 0, 0, 0, 0, 1, and so on and so forth. So I'd like to be able to specify that the positions will actually snap to some specific point. So what I'll do here in mouse tracked, I'll introduce a new boolean specifying value of with name snap. And a getter for it. And the controller for mouse will also check whether a specific key, and let's go maybe with a shift key. So boolean snap GDX input is button pressed. No, not the button, sorry, is key pressed, and we are interested in keys shift left or shift right. So if shift is not pressed, it will be not snapped. So by default, it will snap. So if you press any of the shifts while moving your mouse, it will have a snap effect. So it will snap to the nearest coordinate. And in the renderer here, we'll do if mouse tracked is snap. So if we are doing snap, then we'll be rounding. So math util round is value if it's a snap. So maybe let's do this. If snap, else no snapping. Round. Okay, so now if a shift is pressed, it will not snap. If the shift is not pressed, it will snap to the nearest position, Okay, so this is how it looks when I don't press shift. However, when I have pressed shift, I have full control of whatever I want to place it. Otherwise, it snaps nicely to full position. And okay, so we got that part. And what I want to do now is that whenever a mouse is pressed, I want to actually place a block in a specific place, in a specific point. So first of all, in the mouse controller, I'll have a receive event mouse pressed, and the event is actually Let me check what was the event name. It's touchdown. Touchdown. So when this happens, I want to, once again on the level entity, send an event. Place object. It's going to be an event. There's no how it could use the touchdown in the other one, but I want to have separate different scheme of controls, maybe for desktop version of the application and different set of controls for the iPad or any other screen. So I want to translate this, which is responsible only for knows how to work with mouse, translate into the actual editor events. So place object event, and then the same for mouse tracked. And the sending then can be done in a case of, for example, touch screens, that whenever I don't know, they're going to be wrong press or just moving stuff. I don't know how it's going to be done on a different screen, how the control scheme for a different application, which is going to be using touch screen, is going to work differently. And we just want to all of the application work with these events. So this is like the position where something is happening, and this is a request to do something, to do the actual placing of something in the specified position that was last sent by this event. That way, when I go to touchscreen, I can do it just to place this kind of class that translates the actual events that are happening that are dependent on the type of the device into the events that are these two events that are specified, that are understood by the rest of the application. Okay, so now we have the place object event. This is rendering. I want to have a separate one, so let's create here a logic. Maybe editor logic system. No, not packaged. I want to have a class. Profiles, game screen, and editor. And here I have same thing. So last mouse position, which is going to be vector 3, and I will receive the event. And it's going to be the same as the selection renderer. So we have the same logic. And in addition, it will have to have the level entity. It's going to be the same thing as in the mouse editor. And whenever the place object event happens, actually I don't have to, because the place object is called on the level entity, so I don't have to get it here because I get it for free here. So whenever place object is called, I need to place the object at this last mouse position. So get block coordinates. I need to put at the, so I have to construct the position, so it's going to be last mouse position X plus last mouse position Y last mouse position Z. I want to specify what is placed there, and what is placed there is specified by the block type selected event. So last selected block type, and have the event here. No. Last block selected blocks is block type selected get prefab name, and in here I'll specify last selected block type, and we only want to do it if the actual block type is not null. So if it's null, we don't place anything. So if no block is selected, we don't. Whenever the user presses the button, we don't place anything. Okay, so this is almost done. So we'll be modifying the component. Now we have to set to I have to make the level component have a setter for this. And I have to make sure that the entity is saved. And so this is going to be updating the actual level component that we are working on. However, it will not recreate the mesh that is used for block by the block renderer. So to do that, I'll have to create a new event. It's going to be in block renderer, which is going to be rebuild block mesh. And in the block renderer, I will receive this event. And I'll have to do these things. So first of all, let me do this. Extract a method for the creating the mesh. Or yeah, creating mesh, and I'll have destroy mesh. And in the rebuild block mesh, I'll call destroy mesh and then create mesh, passing the level entity. So now the last thing that we have to do in the editor logic, after saving the block, I have to, on the level entity, so this one, I have to send an event, rebuild block mesh. So after I modified the actual level component, I have to tell, okay, now you have to rebuild it so we can render it with a changed block. Okay, so let me check if this works. So I press button, nothing happens. However, if I choose stone, I can now create stone wherever I want to. And this is going to be saved in the level component. Okay, yeah, I think that's a good point to stop working on this for this. That's a good point to stop this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter, links in the description. Thanks for watching. Bye.